Today I'm going to be walking through my lab setup for deploying followers in a Kubernetes cluster using CyberArk's Dynamic Access Provider, or DAP. And we're going to be deploying onto Amazon Web Services using EKS, or Elastic Kubernetes Services, and ECR, which is an Elastic Container Registry. So one of the issues that we have with our current documentation is that it combines a lot of steps. There's a lot of context switching. One of the things we do first is set up DAP, and then we jump over to Kubernetes, and then we go back over to DAP with Kubernetes. And this makes some assumptions about the rights that we have. The demo I'm doing today is going to actually break this into 3 steps. Before we have some prerequisites that we're going to set up. So if you already have a Kubernetes cluster and a Conjure master to work with, then you can largely ignore these prerequisites. But the 3 steps that we're going to go is preparing Kubernetes as the Kubernetes cluster administrator. And then we're going to hand off some information to the DAP administrator to populate the authenticator values. And then once that's complete and ready to go, we can hand it back over to the cluster administrator, who can actually deploy the follower into Kubernetes. This repository has some general steps, and I will be updating this to be a little bit more inclusive here. But in general, we want to create a jump host and a DAP master. We're going to load some stuff into ECR, making the containers available for consumption in EKS. And then we're going to step into the rest of the steps here. The first thing we want to do, the other thing is that we are using some utilities here to make this work easier. So EKS util, or CTL, is a CLI for Amazon EKS. It's written by Weaveworks, excuse me. You can install it on Mac, and in this case, we're actually just going to download directly. We're also using kubectl, which is a Kubernetes cluster management tool. And these both leverage the AWS IAM authenticator so that we don't have to do a whole lot of authentication to EKS. It's handled via IAM rules. So let's jump into this. The first thing we need to do is create some hosts. We want to go over to Amazon EC2. We want to launch a jump server using the Amazon Linux 2 AMI. We can leave this as T2 micro. This is just a staging box for this demo. But we do want to make sure that we get a public IP address here. I go ahead and throw 30 gigs onto there so that, since it's free, I'll call this demo jump server. Create a security group for this that allows public SSH. We'll create a new key pair for this. So that's being launched. The second thing we want to do is stand up a Dynamic Access Provider master instance. We'll go over here and launch that as well. For this, you should have the AMI shared to your Amazon account. You should see the latest here. In my case, this is DAP 1010. Our minimum requirements for that do require you to go with an M4 extra large, which is not free tier eligible. We also want this to be publicly accessible or have a public IP so that the Kubernetes cluster can reach out to that public IP for communication. I'll give this a name tag so it's easy to find. For the security group here, we actually want to give this a few other things. So I limit SSH access to my jump server. And then we want 5432 for database replication between the master and the followers. 1999, which is also publicly accessible for syslog audit replication. And finally, we want 443 for web services or API access. I'll go ahead and use that same key pair. Launch my instance. So my jump server is ready to go. What I'll go ahead and do, I'll copy this public DNS here. Jump over to our terminal. Grab my demo key and put it in my SSH directory. Then, just for ease of use here, go ahead and export some variables to make SSHing a little bit easier. Amazon AMI, default user is EC2 user. So let's go ahead and jump on there. And our instructions, the next thing that we actually do is create some ECR registries as well. But first thing I'm going to do is actually copy this setup script over to the jump host since it's missing some prerequisites. Go to my setup script and go to raw and copy this URL. Download that. Execute it. What this script does is it installs JQ, Docker, and Git, then installs kubectl, AWS IAM Authenticator, and EKS CTL. Adds my EC2 user to the Docker group. It starts and enables the Docker service, and then it drops me into a prompt to configure the AWS CLI, which is required by EKS CTL in order to build the cluster. So while that's running, let's go ahead and jump over here to ECR. We'll go ahead and create our registries. So if you have no registries yet, you'll have this get started here. One called seed fetcher, which will be for the init container. We want one for the Conjure appliance itself, which will be used to run the follower in Kubernetes. Make note of this value here. This is your registry URL. I'm just going to go throw this in a notepad real quick, but we'll put that in a config as well. I'm going to pause and put in my AWS credentials here, and then we'll get back to this. Okay, now that I've put in my AWS credentials from the setup script, I'm going to go ahead and log out and just log back in. What that does is it adds the Docker group here so I can execute Docker commands. Finally, I want to make sure that my AWS CLI is configured correctly. See that I can actually get the user that I'm logged in as. The next thing that we want to do is clone this repository. Now that we have Git on this host, we can come here, clone my repository onto the host. Now that we've cloned the repository, step in there and make a copy of this config template and edit the config. The prerequisites here include the configuration of the Kubernetes cluster as well as the configuration of the DAP master. If you already have these, you can put in your values here. I'm going to go ahead and accept the defaults for the demo purposes. They're already filled out. This is your DAP account, your administrator username, which is admin, the password that we want to set or that is set. This is the namespace where we will be deploying the followers into Kubernetes and the version that we want to deploy. Finally, we want to grab our ECR base URI, which is the value that we get here. You'll notice it's the same for both registries. So I also don't need to change that there. These are populated with values previously set, but we do need to change our internal DAP IP address here. We get that from our EC2 instance. We also want to provide the proper key here. Key name was demo. And then we want to give the public DNS name for our master instance here. This is what will allow Kubernetes cluster to speak to the master over the public internet. Finally, we want to specify what our Authenticate's branch name is going to be. And in this case, I'm calling it EKS-dev. I want to run 2 followers in Kubernetes. My service account is called conjure-cluster, and my app name is conjure-follower. And that's important for the service that will be exposed, allowing other deployments to communicate with these conjure followers in the Kubernetes cluster. Finally, we have our host name that's generated based on all that information above. So we see our branch name here, our follower namespace, and our service account name. This information below here can be ignored if you're working with an existing Kubernetes setup. If you're not, this is what determines how EKS is deployed. In this case, I'm using Kubernetes 1.13, and I'm using M4 extra large instances for the worker nodes. So we'll go ahead and save this. The other thing I do is copy my jump certificate to my jump box so that I can use it to communicate to the master. So yeah, you notice that I've uploaded that. And that corresponds with the value in that config file here. Now that we have all that set up, we can go back to our instructions. We've done this step. And now we step into each directory and run our scripts. We've already run the setup script, so we need to start with initializing the Docker registry. What this step does is it pulls the seed fetcher and pushes that into our local Docker registry, then pulls the Conjure CLI for further use after everything is deployed. And we'll also SSH to the DAP master and export the current appliance container and import it into our local registry, or our local Docker instance. So these are the steps you see here on 17 through 19. I'm going to pause the video because the export and import does take a little bit of time. Okay, we're back. We see that we've actually exported that and loaded it into our local registry. If I look at the images that I have on my jump host here, you see the seed fetcher here tagged as latest. I also see the Conjure appliance tagged with 1010. I see that I have my Conjure CLI version 5, and these two are related to building the seed fetcher. The next thing that we do for prerequisites, this step can be skipped if you have a Kubernetes cluster already configured somewhere. The only thing you would need to do is configure kubectl to talk to your cluster. This demo, I'm going to go ahead and run my K8S cluster. This uses the AWS CLI to create an EKS instance. It uses the default VPC and automatically puts nodes in public and private subnets and exposes the control plane publicly. I'm going to pause the recording again. This does take 10 to 15 minutes, depending on EKS build processes. We're back now that the EKS cluster is completed. We see that we have some nodes that are ready, some that are not ready. Finally, that this cluster is ready. We can verify this by using kubectl. We do see that here's our server. We can also look at the nodes that have been deployed. We now see that all three of those are ready as well. The next prerequisite that we need to fill, again, you can skip this step if you already have a DAP master deployed and available, is to configure the DAP master. In this case, we're just deploying a single master using the values that we set in that config file. What this is doing is it's SSHing to the DAP master instance, running evoke configure master, providing the public DNS of the EC2 instance, the password that we set in the config file, and finally setting the account name to demo. While that's finishing, we'll go back here and we see that our prerequisites are done. This is actually where the integration work begins. Once we have our prerequisites in place, we have a Kubernetes cluster available, we have a DAP master available. We actually want to step into the role of a Kubernetes cluster administrator, and we'll do a bunch of preparation work in Kubernetes in order to both set up the environment and set up the or gather information that's required for the configuration of the authenticates authenticator. First thing we want to do is push our containers to the repository that Kubernetes will be referring to when it pulls images. So this first step, we log into ECR using the AWS CLI, and then we tag our repository or our local images with the URL of the repository where we want to push them, and then we push those images. We do that for both the seed fetcher image and the Conjure appliance image. Again, the seed fetcher is used as an init container that fetches the seed file used in the configuration of the follower. And the Conjure appliance image is used to operate that follower. Okay. We see that our Conjure master is up and running. We can verify that by looking at the master. Go back over here and just grab the public DNS. Look at the health. See that we have an OK true. The other route we can look at here is info, and we see that while we have installed authenticators and Authenticates is an actual installed authenticator, it's neither configured nor enabled. This is one of the verification steps we'll take later to check that the authenticator is properly available. So these steps are all completed by the Kubernetes cluster administrator. This is one of the confusions in our current documentation, is that it assumes that we have rights to both systems. We can actually split that out and prepare Kubernetes and gather the information required and then hand that off to the DAP administrator. The first thing that we want to do is push those images. In this case, we're using ECR. We have a lot of customers that use JFrog Artifactory or other Docker registries. As a side note, if you're using OpenShift container platform, this is one of the steps where OCP actually contains an internal registry where you can push these container images as well. Because I'm using EKS and ECR, and I use the EKS CTL command to create my cluster, we actually don't need to provide Docker login credentials. Behind the scenes, everything's being configured so that the EKS cluster has direct access to ECR without Docker login credentials. If you are using a different system, you will need to provide the Docker credentials. And this is this optional step here. So in this case, again, because I'm using ECR, I've provided an example of it, but it puts out, this command actually writes out a Docker login command, and then taken that output and parsed it to get my username, my password, and the URL to log into. That should be information that's available to you from the maintainers of the registry. Now we see that these images have been pushed to the registry created in ECR. We also see that what we did was locally we tagged those images with the URL where we wanted to push those images. So there's your seed fetcher. And we also tagged the Conjure appliance. So if we head over to ECR, we can see in our repositories that we created earlier, the Conjure appliance now has a 10.10 tag, and our seed fetcher has a tag with the Kubernetes namespace name where we will be deploying our followers. These image URI URLs are the ones we'll provide to our manifest when we go to deploy the followers. Next thing that we need to do is go ahead and prepare our Kubernetes cluster. This includes creating a namespace for our followers and creating a service account for that to use to connect to other pods that are requesting authentication. That service account also provides the token that we will use to authenticate to DAP master. What I've done here is I've substituted some templates, tokens, Conjure role template, creates our Conjure role manifest. And all these steps can be run manually, of course. Just a script to simplify that. So finally, we apply that manifest. Then since we have a namespace now where we want to work, we use kubectl to set our context to that namespace. The other thing that the followers will need is the DAP master server certificate. So we use OpenSSL to connect to our DAP master instance, retrieve the server certificate, and store that in a config map. The config map is called server certificate, and the key is SSL certificate, and that has the value necessary for the followers to connect to it. So go ahead and run this. See our substitution occur, and then we see once the manifest is applied that our namespace is created in Kubernetes, our service account is created. We create the cluster role that allows the service account to query other pods, that provides the authentication token. The followers could connect to the seed service. We see that role binding apply that cluster role to the service account. The other thing we do here is we create a service that once the followers are deployed, we'll expose those followers to other pods requiring authentication using authenticates. One thing you may want to do is take a look at this manifest that was created. So if we look here in the directory, that template that was used earlier creates this conjure role manifest. And what we see is that we've done several substitutions. So let's look at the template actually. So here we can see these tokens where values are needed. And this is information that would be provided by the Kubernetes administrator. So the follower namespace, the name of the service account that's going to be created, etc. And then also the app label that will be used for the follower services. Again, that's using substitution. We've filled all that in using values from our config file. The next thing that we need to do is collect information for our DAP administrator to configure the authenticator. Our Kubernetes cluster is now prepared, but no services have been exposed yet. What our gather information script does is it collects information, and we see this in our steps on our website, where these steps assume that we have both Kubernetes cluster administrator rights as well as conjure rights. We've actually taken that and split that up. Some of these are Mac specific commands, so our base64-D here, the -D is actually Mac specific and does not work on Linux machines. So looking at this, what we've done is only pull out the Kubernetes commands needed to collect this information. And then we store that in a JSON file that we can provide to the DAP administrator. Some of this is sensitive information. So this is our service account authentication token. The API URL is not sensitive. Our CA cert is also not sensitive. This is information that can be publicly retrieved, but our service account token is sensitive. So you do not want to keep this file on disk, or if you will be using this, make sure to transmit this to your DAP administrator securely. Now that we've finished with the preparation of the Kubernetes cluster, we can step into the next part. This part is completed by our DAP administrator. To this point, no communication has occurred between DAP and Kubernetes. These are two separate roles. So the first thing that we actually want to do is load our policy, create our policy that will be loaded to enable the seed fetcher service and to configure the authenticates authenticator. This first script, again, what it's doing is taking a template file, it's root YAML template, and doing some token substitution on it to produce our root.yaml, which is our root policy. If you already have a DAP cluster or DAP master, you would need to review this and make sure that there's no conflicts with existing policy, or find a strategy for incorporating this policy into your existing strategy, into your existing policy. This again, it also takes the template that we have for our Kubernetes follower policy in DAP from the website, but it does complete our substitutions automatically using our config file. We can see here that we have EKS dev, which was specified in the config. We come down and complete our host with our conjure Kubernetes namespace, our Kubernetes service account name. And then here we're granting that host that's generated access to the seed generation service. One of the next steps that we have to do is load this policy and populate those values. Given that we've seen customers that don't have Docker installed on the DAP administrator machine, or where DAP is the DAP CLI is not easily available. So we've taken this and we use raw API calls in this script to populate that information. We can see here we're taking that Kubernetes values file that was produced by our Kubernetes administrator and parsing that. We authenticate using our DAP administrator, get an authorization token. We then load the root policy that was generated from our template. And once that's loaded, we parse that Kubernetes values file and post those values into our secrets. Let's go ahead and run these steps. The first one we want to do is populate. There's not a lot of output here, but we can see that that host was created, which tells us that our policy was properly loaded. The next thing that we need to do, which follows along with our steps on the website, is we need to enable the Conjure CA, the Kubernetes Authenticator. This is executed as a command on the DAP master. So in the script, we simply SSH to that and execute that command. This again uses a substitution here because we need to tell it what policy branch is this being enabled for, where to put those values. And so in our case, this DAP authenticates branch would be EKS-dev. See that value here. Finally, if we looked at our info, what we'll see now is that our K8S authenticator is installed and it's configured now as well, but it has not been enabled yet. Final step in this process for preparing DAP is to enable the authenticator on the master. We do this with a docker exec command by modifying the conjure.conf file to include that authenticator, and then we restart the Conjure service. You can now see that once the service is restarted, we have an installed authenticator that is configured and enabled, making it available for our followers to communicate with. The final step here is to deploy our followers. Now this is something where our documentation again falls short here a little bit. We see that we have examples here of our DAP policy that needs to be loaded. How to do that. We see that we have the preparation step for the Kubernetes cluster. That. We also get the values here, but what we don't see here is the follower manifest to actually deploy the follower. To get there, we need to go to our GitHub repository for Kubernetes deploy. Once we're there, if you look under Kubernetes, you can see a conjure-follower YAML file here. And this provides the template for deploying the followers. However, it does duplicate some information. So we've already defined this service, as well as the service count. So really what we need out of this is this manifest, this deployment manifest. I've taken that manifest and pulled it out directly into a template again. So if we look at our templates here, you can see our conjure follower manifest is available. And again, we're using token substitution based on values in our config file to simplify the coordination of these values. This is the service name that we previously applied, so conjure-follower. The number of replicas that we want to create, again, conjure-follower, conjure-follower. The service account that we created previously. Our seed fetcher repository, our conjure seed generating service. The ID of our authenticates branch, which is EKS-dev, DAP account, and this is for the init container. So what this tells the init container to do is to start up and retrieve the seed from this URL. It's initialized by downloading that image, the seed fetcher image that we pushed to ECR earlier. Once that's complete, what it does is it creates a seed file mount. It puts that seed file and the conjure token that was retrieved into volume mounts, and those are made available to our conjure appliance. Conjure appliance container will start up, consume that seed file by unpacking it, and then configure itself as a follower. If everything goes correctly, we should actually see that come up, replicate the database, and become available to serve requests. Again, the final step here, if you're using EKS and ECR, you do not need to provide a Docker login secret. However, if you're using a third-party Docker registry, you may need to populate that. In order to populate that secret, we actually go back to our Kubernetes preparation step. There's an optional config map here that's created, ignoring this if you're using AWS, but being able to parse this, provide this command here to create that config map. So you need a server, a username, and a password to provide Docker login credentials. So this again is done by our Kubernetes administrator. What we're going to do is some simple substitution, like I said, on that template. Let's go ahead and run that. That produces our manifest, our followers. You can see that everything is populated based on our config file. The final thing that we do is actually deploy our followers. Simply apply this manifest, and then this script also writes out some information, looking at our deployments and our pods. We can use this information if we look at this pod name, and we can look at the logs of the init container, which is called authenticator. We can immediately tell if this is successful or not if the seed file has been downloaded. See the seed file is saved at temporary location. If we look at the logs for the pod itself, it will look at the main container. We can see that those are running. This is probably because it is still downloading the container image. Now we can see that it was able to unpack that seed. Scroll back up here to the top. So it unpacks the seed and begins configuring itself as a follower. Our seed file was successfully unpacked. Begin to run evoke configure follower. Once that is completed, we can actually go back and look at our health on our master. And we'll see that our 2 replicas are actually up and have registered themselves with the master. Finally, once the readiness check has completed and that health URL for the follower returns a 200, we'll see that they become available and ready. Final thing we can look at is whether or not our service is available within Kubernetes. We can use this get services to look at our service. We can describe our service. We can see now that we have an IP for this service, and it has 2 endpoints that are listening, corresponding to our 2 followers that have been deployed. This makes this available as conjure-follower.conjure-dev.service.cluster.local. That's the follower URL that would be provided to an authenticator sidecar. I hope you've enjoyed this demo, and I look forward to any improvements and any requests, any questions that you may have